Hình thành trên cơ sở kế thừa tinh hoa và truyền thống học thuật phong phú của Đại học Đông Dương, Đại học Quốc gia Hà Nội đã phát triển lớn mạnh, khẳng định được vị thế là trung tâm đào tạo, nghiên cứu khoa học, chuyển giao tri thức đa ngành, đa lĩnh vực, chất lượng cao, trình độ cao theo chuẩn quốc tế.
Đại học Quốc gia Hà Nội là tổ hợp bao gồm 7 trường đại học, 5 khoa trực thuộc, các viện và trung tâm nghiên cứu khoa học, hoạt động theo nghị định và quy chế do Thủ tướng Chính phủ ban hành. Ban Giám đốc Đại học Quốc gia Hà Nội do Thủ tướng Chính phủ bổ nhiệm.
Hình thành trên cơ sở kế thừa tinh hoa, vị trí và của Đại học Quốc gia Hà Nội trong tương quan với các đại học ở Đại học Quốc gia Hà Nội đã phát triển lớn mạnh, khẳng định được vị thế là trung tâm đào tạo, tổ chức nghiên cứu khoa học, chuyển giao tri thức đa ngành, đa lĩnh vực, chất lượng cao, trình độ cao nhóm 1.000 đại học hàng đầu thế giới và ở vị trí 124 đại học hàng đầu châu Á.
Đại học Quốc gia Hà Nội là tổ hợp bao gồm 7 trường đại học, 5 khoa mới đây nhất, Đại học Quốc gia Hà Nội trung tâm vị trí số 1 Việt Nam theo nghị định và 77 bậc trên thế giới tại ban hành xếp hạng Webpometric. Ban Giám đốc Đại học Quốc gia Hà Nội cũng là cơ sở giáo dục duy nhất tại Việt Nam có lĩnh vực quản lý thuộc xếp hạng trong 502 toàn cầu trong bảng xếp hạng các trường đại học tốt nhất toàn cầu do báo Tin tức Hoa Kỳ bình chọn.
Sự phát triển của Đại học Quốc gia Hà Nội dựa trên triết lý, đạt đỉnh cao dựa vào tri thức và xoay quanh 6 giá trị cốt lõi: chất lượng cao, sáng tạo, tiên phong, tích hợp, trách nhiệm xã hội cao và phát triển bền vững. Các giá trị này thể hiện mạnh mẽ trong các hoạt động đào tạo, nghiên cứu và hợp tác phát triển.
Trên phương diện đào tạo, Đại học Quốc gia Hà Nội đang là sự lựa chọn hàng đầu của những sinh viên xuất sắc tại Việt Nam cũng như sinh viên quốc tế nhờ các chương trình đào tạo chất lượng cao đa ngành, đa lĩnh vực với hàng trăm ngành, chuyên ngành đào tạo trên mọi lĩnh vực.
Bên cạnh các ngành học truyền thống, Đại học Quốc gia Hà Nội còn tiên phong xây dựng nhiều ngành đào tạo mới, đáp ứng nhu cầu xã hội và cập nhật xu hướng thế giới như biến đổi khí hậu, quản lý khoa học công nghệ, quản lý tài nguyên thiên nhiên, khoa học bền vững, an ninh phi truyền thống, hàng không vũ trụ, quản trị trường học, công nghệ kỹ thuật xây dựng và nông nghiệp công nghệ cao.
Sinh viên của Đại học Quốc gia Hà Nội tự hào được học tập trong môi trường quy tụ lực lượng đông đảo cán bộ nghiên cứu, giảng dạy là các chuyên gia đầu ngành và có đội ngũ giáo sư, phó giáo sư, tiến sĩ và tiến sĩ khoa học đứng đầu trong các cơ sở giáo dục của cả nước. Ngoài ra, sinh viên của Đại học Quốc gia Hà Nội còn được lựa chọn chương trình đào tạo bằng tiếng Anh, chương trình đào tạo liên kết quốc tế, trao đổi tín chỉ tại các đại học đối tác của Đại học Quốc gia Hà Nội trong khu vực và trên thế giới.
Là cái nôi phát hiện và đào tạo nhân tài cho đất nước, nhiều cựu học sinh, sinh viên của Đại học Quốc gia Hà Nội là những chính trị gia, doanh nhân, nhà khoa học nổi danh không chỉ ở Việt Nam mà còn được bạn bè quốc tế ngưỡng mộ. Học sinh khối chuyên của Đại học Quốc gia Hà Nội vinh dự đại diện cho những tài năng toán học, vật lý, hóa học, sinh học, tin học của Việt Nam tham gia và đạt giải cao tại các kỳ thi Olympic quốc tế.
Với định hướng trở thành đại học nghiên cứu chuẩn quốc tế, Đại học Quốc gia Hà Nội tập trung vào 4 lĩnh vực mũi nhọn: khoa học tự nhiên và y dược, khoa học xã hội và nhân văn, khoa học công nghệ và thực phẩm và khoa học liên ngành liên lĩnh vực.
Đẩy mạnh phát triển khoa học liên ngành, đưa khoa học công nghệ ứng dụng vào thực tiễn phát triển của địa phương, của vùng. Các nhà khoa học của Đại học Quốc gia Hà Nội chủ trì những chương trình nghiên cứu tầm cỡ quốc gia, công bố những phát minh sáng chế có giá trị thực tiễn, thúc đẩy những xu hướng khoa học mới và đóng góp cho sự phát triển của đất nước.
Hàng năm, Đại học Quốc gia Hà Nội có trung bình hơn 600 bài báo khoa học ISI Scopus và nhiều kết quả nghiên cứu công bố tại các hội nghị hội thảo và tạp chí khoa học uy tín trong nước và quốc tế.
Những tên tuổi khoa học Đại học Quốc gia Hà Nội được vinh danh tại các diễn đàn quốc tế và khu vực. Nhiều cá nhân, tập thể nghiên cứu xuất sắc đã mang về cho Đại học Quốc gia Hà Nội những giải thưởng danh giá như Giải thưởng Hồ Chí Minh, Giải thưởng Tạ Quang Bửu, Giải thưởng Nhân tài đất Việt và nhiều giải thưởng quốc tế như Giải thưởng Kovalevskaya, Giải thưởng Cosmos, Giải thưởng Hành tinh xanh và Huy chương Pushkin.
Trong những năm gần đây, Đại học Quốc gia Hà Nội tiếp tục được Đảng, Nhà nước và Chính phủ giao chủ trì xây dựng và triển khai nhiều dự án tầm quốc gia như Bộ Địa chí Quốc gia Việt Nam, chương trình khoa học và công nghệ trọng điểm cấp nhà nước phát triển bền vững vùng Tây Bắc và dịch thuật và phát huy giá trị tinh hoa của các tác phẩm kinh điển phương Đông. Các dự án này đã khẳng định uy tín nghiên cứu học thuật và sự kỳ vọng của Đảng, Nhà nước và Chính phủ vào Đại học Quốc gia Hà Nội.
Bên cạnh đó, Đại học Quốc gia Hà Nội tự hào có một mạng lưới hợp tác rộng khắp trên thế giới với hơn 400 đối tác là các đại học, cơ quan nghiên cứu, tổ chức giáo dục trong khu vực và trên thế giới. Trong đó có nhiều tổ chức quốc tế uy tín như AUF, AUN, SATU, UMAP, các hoạt động hợp tác và phát triển, tạo nền tảng thúc đẩy các hoạt động trao đổi nghiên cứu và đào tạo, chuyển giao tri thức, trao đổi học thuật, giao lưu văn hóa trên mạng lưới toàn cầu.
Trong nước, Đại học Quốc gia Hà Nội được tin tưởng trở thành đối tác của nhiều cơ quan, doanh nghiệp trong đào tạo, chuyển giao công nghệ, đưa các kết quả nghiên cứu ứng dụng vào thực tiễn, đồng thời tư vấn chính sách, góp phần giải quyết các vấn đề của doanh nghiệp và địa phương.
Quan tâm đặc biệt đến sự phát triển của Đại học Quốc gia Hà Nội, lãnh đạo Đảng và Nhà nước đã thường xuyên đến thăm, lắng nghe nguyện vọng và chia sẻ những khó khăn của tập thể cán bộ, nhà khoa học của Đại học Quốc gia Hà Nội. Để từ đây, ý chí và tinh thần của Đại học Quốc gia Hà Nội đã được thực hiện hóa thành những giải pháp mới, những nỗ lực sáng tạo mới.
Cùng chung giá trị và lý tưởng trong hoạt động khoa học, nhiều nhà khoa học, chính trị gia nổi tiếng thế giới đã đến thăm và đóng góp sức mình vào sự phát triển của Đại học Quốc gia Hà Nội, của nền khoa học giáo dục Việt Nam.
Nỗ lực không ngừng nghỉ để phát triển, mở rộng, hướng tới việc xây dựng một cơ sở giáo dục đại học hiện đại trong khu vực và trên thế giới. Đại học Quốc gia Hà Nội đang ấp ủ xây dựng một thành phố đại học trong tương lai, nơi Đại học Quốc gia Hà Nội tiếp tục cam kết thúc đẩy các hoạt động đào tạo, nghiên cứu, hợp tác trong nước và quốc tế, đào tạo sinh viên trở thành công dân toàn cầu.
Đại học Quốc gia Hà Nội cam kết đóng góp vào sự hòa bình, ổn định, phát triển thịnh vượng của quốc gia, khu vực và trên thế giới.
Chị Sơn chưa một tiếng.
Can you hear me?
Yes, I can hear you.
Okay. So, sorry. So, okay. Sorry. Oh, okay. Thank you so much for all the members to come here, and I guess that now we start the international workshop on smart health in the age of AI, and it's my honor to present and welcome Professor Trần Xuân Tú, the directors of the Vietnam National University Information Technology Institute here. Professor Tú, yeah.
Good morning, everybody.
Good morning. And I would like to say welcome to Professor Chuan Wu Chang, director of ICE Centers from Yulin National University of Science and Technologies in Taiwan, the co-host of our workshop today. And now, as you know, that we also have a very strong research on the smart hospital, smart health in Vietnam National University in ITI for last 5 years. And we also open and organize so many conferences and workshops till now. And up to now, we are happy to organize another events on smart health. And with the light and ideas of Professor Tu and Professor Chuan Chang here, so our focus of workshop today is to bring some new research and technology regarding the smart health to all of the audience, and so we hope that it is a safe forums for cooperation between the smart health, between the VNU ITI and UNITEX University, and to create some opportunity to learn, exchange, and research, and also to contribute some development of science and technologies in smart health in both university. So first of all, I'd like to say if I like to invite Professor Tu to have some word before we start the workshop. So please.
Can you hear me?
Yeah. Yes.
Okay. So thank you very much. So dear ladies and gentlemen. So on behalf of the Information Technology Institute, a member of Vietnam National University, I warmly welcome all of you to the international workshop on smart healthcare in the age of AI. And the workshop is co-organized by VNU Information Technology Institute and the Intelligent Decognition Industry Service Research Center from National Yunlin University of Technology, UNTEC. So VNU Information Technology Institute is a public institution established by Prime Minister with a mission to conduct education, training, and to foster talents, providing highly qualified human resources at higher education levels to conduct research on development and application of advanced area of science and technology, and to effectively contribute to the development of the knowledge-based economy and society of the country. So to pursue the above mission, our institution has established a cooperative exchange by forming partnership with university and institution overseas, and by encouraging academic and research exchange. So we expect today workshop will provide an open, friendly forum to discuss leading edge research and development subjects of applying ICT technology to smart healthcare, which has served as a vehicle for a variety of exchange and interaction among researcher and engineer, industry and academy in the life of everybody. So we do hope that all scientists who will participate in this workshop will maintain their cooperative relationship in the future. So let me sincerely thanks to all the participants for their contribution and great effort to organize this workshop today, especially Professor Chang Chuan Yu and Professor Chang Xuan Ting from UNTEC, and Professor Lê Hoàng Sơn from our VNU ITI. And finally, I wish all of you a successful workshop and a good health. And thank you very much for your kind attention. Thank you.
Thank you so much, Professor Tu, for a very warming welcome speech. So the next one, so we would like to invite Professor Chuan Wu Chang. We have some speech, welcome speech. So please.
Okay, thank you, Professor Sum. Okay, may I show my slide here?
Yes.
Yeah, please give me the priority to share my slide.
Yeah. Please.
Yeah, I do not have the priority to share.
Can you share now?
Okay. No, I cannot share my slide.
Oh, please wait. Can you, are you able to say now? You host now. You host now. You host.
Okay. I'll try again. No, I cannot. Okay.
We just set you your host, the co-host now, so you can easily say by clicking the button in the middle, sharing.
Okay. Can you see my slides?
Yeah, sure.
Okay. Okay. Thank you, Professor Sun. I think I will try to find about a few minutes to introduce our university, National Union University of Science and Technology, and the Intelligent Recognition Industrial Service IRIS Center to you. Okay. National Union University of Science and Technology was founded in 1991, and UNTEC has 5 colleges: the College of Engineering, College of Management, College of Design, College of Humanities and Applied Science, and the College of Future. The student population is approximately 10,000. 68% of whom are undergraduates and 22% are postgraduates. UNTEC is a flagship technological university in Taiwan. UNTEC is the top 3 university of science and technology in Taiwan. And in Times Higher Education's various ranking, UNTEC performance is quite good. UNTEC also received the Green Metric World University Award and the Taiwan Paradigm University Sustainability Awards. And about the IRIS Center, with the increasing development of computing performance and AI, the IRIS Center has been dedicated to developing AI technology that can be practically applied to industry for a long time. In 2018, the IRIS Center has received support and funding from the Higher Education Sport Project of the Ministry of Education, Taiwan, and has been selected as a featured area research center. IRIS Center consists of several AI experts and full-time engineers and an industrial service team. Currently, I am the director of the IRIS Center. The IRIS Center mainly develops intelligent recognition technology to assist the industries such as intelligent detection, smart healthcare, and intelligent living. IRIS has developed close to 100 new technologies and consult over 300 enterprises. Moreover, 90% of the developed technology has been practically applied to related fields. The IRIS Center introduced intelligent recognition technology to industry and actually help them to solve problems and improve efficiency. We focus on developing intelligent inspection tools for manufacturers and intelligent medical image processing technology for precise clinical diagnosis, and infant crying recognition system to help new parents to understand why their baby crying, and UAV image recognition technology for inspection of ground facilities and environmental inspection. So I think based on this research topic, we are searching for further cooperation with VNU. Thank you.
Okay, so thank you so much, Professor Chuan-Woo Chang, for your very quick and short introductions about the IRIS centers and your achievement and your main research of interests. And we hope that after we and your Croatia will present your research, and we can reach some common research at the end of this workshop. And now, thank you, Professor Chuan Woo Chang, for your introductions. And before we come into the main part of the workshop today, may I remind again some program and agenda. Let me say again. Okay, so can you see my slide?
Yes.
Okay. Okay. So I am skip again only this part because he was introduced by Professor Du last time. So I just quickly turn to some achievement on smart health. This is the history of our some international conference and workshop on smart health organized by our institute in the last 3 years. For the first workshop, we organized in 2019, first workshop, and the second workshop we organized in the last year. And here's some picture of the workshop in a first one. First one with many delegations from Korea and Taiwan and Spain and so on. And and this is the workshop in the second one in the last year. We have so many delegations from companies both in Vietnam and also in foreign countries. Here we really present so many good results both on and X-ray image and blockchain and AI and so on. As you can see in the slide. And now the program for workshop of the VNU, ITI, and UNTEX. For the first 3 presentations from our side, we have 3 presentations. For the first one, we'd like to introduce Dr. Ravindra Kumar. He's the associate professor in GIIT University in India. Now he also a postdoc student in my lab. And he will be present a talk about the develop internet system based on the cloud things. And the next one, we have the presentation from the Dr. Land. Dr. Land, she will present some new learning model. It is inspired by convex poly transferring model and applied for disease diagnosis. And the last question from outside, we will have a talk from Mr. Phạm Hải Sơn. He an expert in Ministry of Science and Technology in Vietnam, and he will be present for us solutions for developing a more health enterprise architecture frameworks, which he remain research in long time. And after we have presentation from outside, the 2 presentations from UNTEX is from Professor Chuan Yuan Things with the title "Detection of Long Lessons in Trust X-ray Image Beyond AI," and the last one from Professor Chuan Woo Chang with titles for the vision-based facial head rate and respiration detections. So we hope that we will have so many good and useful informations and knowledge after we hear on the presentations here. And I would like to recommend if anyone here in the workshop we have any questions, please give a question in the chat box, or you can ask a question in the last part. We discussions after all the presentation finish. Okay. So Now we would like to invite Dr. Kumar to present the first one, the first passion. Dr. Kumar, are you there?
Yes, sir. Good morning, sir. Good morning to all
Good morning.
the professor and all the students.
Yeah. So can you show me your image, right? Okay. So thank you.
Morning, sir.
Yeah, morning. Okay, like can you share your slide? You can share your slide.
Yes. Sir, please stop your sharing the screen. After that, I am able to share the screen.
We also open the sharing functions.
Yes, sir. Yes, sir. Please stop sharing.
Yeah.
I hope the screen is visible, sir.
Yeah, we can see that, but can you make your slide full screen?
Now it's visible, sir.
No, it was still not full screen. Can you, or you can press F5 or so on?
Now it's visible, sir. Now it's okay, sir.
Okay, so you can go ahead.
Now it's okay, sir.
No.
So maybe you use two screen. It's fine now.
Yes. Now it's okay, sir.
Okay.
So good morning all. Here is Dr. Raghavendra Kumar, working as Associate Professor in Department of Computer Science and Engineering in GIT University, Gunpur, India. So my topic is like prediction and analysis of biological data in the cloud of things environment, cloud of medical things environment. Okay, so first we have to understand like what is the IoT and what is the cloud computing, because it is like if we are talking about cloud of medical things, it means we are going to integrate the cloud. We are also going to integrate the IoT, and we are going to analyze the data, and that particular data is the biological data, or you can say the healthcare data. So in the IoT, if we are talking about IoT is simply the Internet of Things. It means that we have the smart devices, or you can say we have the device, or and the devices are integrated into the internet. They are connected with the internet. Then after that, if we are trying to gather the data from the different devices, okay, different medical devices, then the problem is came where we have to store that particular data, because you know the medical data is very, very sensitive data. So in the cloud, if we are going to store that kind of data into the cloud environment, so the problem is came how we are going to store that particular data, and how we are going to provide the security in that particular data when the data is stored into the cloud environment. So we have to like manage the data, and the like medical data is very, very sensitive data. So we have the different different deployment model. Like first we have the public models, we have the private model, hybrid model, and also we have the community model. So if the information is more sensitive, so we are trying to store that particular information into the private cloud, so that we are going to secure our data from unauthorized access, or you can say the unwanted people who is going to access your data. Because anyhow, we have to preserve our data from unauthorized access, or you can say the unauthorized user. Okay, so in this particular work, we are trying to analyze that kind of data, and mainly we are focusing on the COVID-19 data. Okay, because like you see in the previous last 2 years or 3 years, like the entire world is suffering with the COVID-19, and nowadays it's also going on. We cannot say that like it's over, but it's like the speed of that particular spreading is going slow down, but it is going to affect in all the areas. It start from the education, it start from the marketing, business, healthcare industry, pharma industry, environment, everywhere the COVID-19 is going to affect. So how we are going to predict whether the COVID person is going to suffer with the COVID-19 or not? And also like sometimes we already discussed, like the medical data is very, very sensitive data. If, for example, if we are going to deploy the sensors into the patient body, and we are going to capture the information from the patient, and that particular information, and again we are going to store into the cloud environment. Okay, at that time when we are going to capture the information from the patient, and we are going to store the information into the cloud environment, in the meantime, if the third person is came into the picture, and the person is trying to like hack the data. So if we are unable to provide the security of that particular data, so it is very, very easy for the person to hack the data. Okay, so we have to apply some security mechanism. Like there are different kind of data that we have. Sometimes we have the text data, sometimes we have the audio data, sometimes we have the video data, sometimes we also have the image data. So how we are going to provide the security, and how we are going to analyze, and how we are going to predict whether the person is going to suffer with the corona positive or not. Like if example, if we are going to consider the example, if the person is not suffering with the COVID-19, and we are going to deploy the sensor, or we are going to deploy the different devices over the patient, at that time, if the third person is came into the picture, and the third person is going to hack that particular patient information, so that the person is going to, the middle person is going to modify the information. Once the information is going to modify, on the basis of that particular modified data, if the data is available into the cloud environment, so the person is going to analyze that particular data, and after that they are going to take the decision whether the person is going to suffer with the corona positive or not. On the basis of that particular modified data, the like different analytics is going to give the decision. But in case it is not the actual data, it is not the actual data, it is the modified data. So it is also going to give the wrong diagnosis report. On the basis of that particular diagnosis report, the doctors, or you can say the different application providers, start working on that particular report. Once the analysis is completed, then after that they are going to take the decision whether the person is going to suffer with the COVID-19 or not. Okay, in the meantime, if like a person is negative, but a report is showing that the person is a COVID positive. Okay, so there is a mismatch between the COVID-19 positive person and the negative person, and the doctor is going to give the decision. So in that case, we have to secure our data while we are going to transfer our data from the device to the environment. Okay, and you see the COVID-19 is also affected in the like sexual life, and also the sexual behavior, reproductive planning, mental health, physical health of all the peoples. Okay, so it is going to affect in all kind of all the areas of the science, technologies, and also in the engineering. Okay, so in this case, like here we study the various literature survey that are already published with the different professors. Like they are going to use the different models to analyze the data, that is COVID-19 data. Okay, so like sometimes they are going to use SIR models, sometimes they are going to use logistic and Gomez models, and SEIR, and also the regression concept to analyze that kind of data. Okay, and after that, like if we are talking about like pandemic on the sexual and the mental health, so we are going to study the different literature survey that is already published by the different professors. Like they are going to investigate whether the person is affected with the COVID-19, and if the person is going to affect in the COVID-19, so what is the effect that is going to occur in their daily life, or you can say what is the different effect in the sexual life and also the like the child. Okay, so you see the aim of the COVID-19 is to stressing the sexual and compulsive symptoms and also prescribed social support. Okay, so they are also going to address the different social support and symptoms of the sexual compulsions, and also the regression analysis we are going to use to analyze that kind of data. Okay, then after that we also find the different concept, and also like we have the different research finding with the COVID-19 person, and that is also use a different kind of data. Sometimes we are going to use the CT scan images, sometimes we also using like X-ray images. Okay, and we are going to identify, like there are a number of professors who's going to identify the different accuracy level. If we are going to use like CT images, so what is the accuracy level of that particular data we are going to use? Like sometimes it is going to say like 89.5%, and if we are going to use the X-ray images, so the accuracy level is also going to increase like 97% as compared to the CT scan images. Okay, then also if we are going to use like CXR images, based on the CXR images, how the COVID-19 is going to analyze, and like we have the different kind of data. Sometimes we are going to use text data, audio data, image data, video data. So we are going to analyze the entire data set with the different models. Okay, there are different professors who's going to use a different kind of models. They are design the different machine learning models. They are going to design the different deep learning models. Okay, so and they are going to achieve the more accuracy, like in the binary differential CNN models, they are going to achieve the accuracy of 99.43%. Okay, then you see in our research work, we are going to use like different like models to analyze the data, that is image data. Like we have the Worosz models. The Worosz model is the concept of the populations of the growth by modifying the exponential growth formulas. Okay, and also we are going to investigate the risk factor of the certain disease, and also we are going to estimate the probability of the certain disease that may occur with the risk factors or not. Okay, then also we use a different Gomper models. In the Gomper models, they are going to use the sigmoid behavior type, and also it is going to find the whether the biological is work or not, and we are going to use this particular models for the animal population growth for describing the population of the extensions law. Okay, and you see here you also collect the data from the different sources. Like sometimes we are going to collect the data from the Kaggle, and sometimes we are also prepared some like form, and we are going to take the survey from the different peoples in our country and also from the outside country. Then after that we are going to analyze whether this particular thing is also happened with the country, and this thing is also happened with the person, whether the person is capable to give the answer or not. Okay, then after that we are going to like propose one algorithm, and that particular algorithm, like we are going to start with the input of the time space. Okay, and the t is the 1 to n, and we are going to define like theta is greater than 0, and then we want the predicate, the confirmed cases. Okay, so we are going to analyze the data within the time frame. Okay, within the time spent, like we are going to analyze the data for the 1 month, or we are going to analyze the data for the 1 week. Okay, so here you see in the step number 1, we are going to give the equations, and we are going to calculate like ft and yt. So at ft, like we have the theta 1 is the asymptotic, and theta 2 is represented the displacement along the x-axis, and theta 3 is going to denote the growth rate. And we are then the expression that we discuss is the Elliott numbers. Okay, so here we are going to calculate like yt value. Yt is equal to theta 1 divided by 1 plus theta 2 into the expression minus theta 3t. Okay, then after that we are going to fit the curve with the t and cr and set the initial parameters like p0 is equal to add into mean of c. Then after that, we have the respective theta 1 and theta 2 and theta 3. Then after that, we are going to use the loop from I equal to 1 to n. Then we are going to calculate, call the function ft with the t and the optimal parameters, and we are going to again obtain in the step number 2. And you see, like we are trying to minimize the error. Okay, and also because our expected value is a different one, and the actual value that is came is a different, so they have some error. So we have to identify that what kind of error it is going to occur in our data set and also in our result. So we are again going to calculate like yi is equal to average of the fti and to theta I plus gti into theta I. Then we are going to use epsilon I. Okay, again, then after that we are going to calculate the regression coefficient. So the R square is equal to 1 minus summation I equal to 1 to n yi minus y cap whole square divided by I equal to 1 to n yi minus y cap y bar whole square. Okay, and then we are going to return to the number of confirmed cases, and then that particular confirmed cases is going to denote with the C, and then the algorithm is going to stop. You see here in this particular graph or this particular result, you see we have the like actual and the different models that we are going to use. Okay, now you see our proposed model is going to give the better accuracy as compared to the other models that is already exist. But you see in the actual models, like the red line is going to denote the actual models actual that is required, and we are going to use like Wurstel and the Gompertz model, and that particular model is very far from the actual models, and they have the more errors as compared to our model. Okay, and after that you see there are relative few studies that is also going to affect like in the sexual and the mental health on the COVID-19 on the Indian population. We are going to analyze the data that are related to the Indian population. Okay, so you see the COVID-19 is mostly affected in all the areas. It is not affected, like you cannot say that it is not affected with the business, it is not affected with the social life, it is also affected with the employment. Okay, so we are going to prepare one Google form, and in that particular Google form we are going to design the different questionnaires. We prepared the different questionnaires, and we are going to circulate that particular questionnaires and the Google form to all the pupils, and we collect approx like 900 plus 9,000 plus data from a different part of the country, and we are going to analyze the data by using the different parameters. Okay, because on the basis of that particular question and answers, we are going to analyze that. Like this particular COVID-19 is mostly affected in all the areas, including like sexual life also. Okay, and also in the mental life, mental health care. You see, the statistical analysis was performed using the ordinary least square OLS, and based on the multivariate logistic regression analysis. And you see the outcomes were obtained using the study specific questionnaires to assess the quality of the sex life, changes in the sexual behavior, and the mental health. And you see if it is also affected the frequency of the sexual intercourse and the frequency of the watching porn, sexual hygiene, frequency of physical activity, depressions, desire of the parenthood in the male and female. You can, and it is like effective in both the cases, like male also is going to affect with the COVID-19 and female is also going to affect with the COVID-19. Okay, you cannot differentiate with the male and female, like you cannot say that male is more effective as compared to the female. Okay, both are affected with the same. Okay, analysis of the sexual behavior before and after during the pandemic of the both and male and female. So we are going to analyze once we have all the data set. Then after that we are going to perform the analysis on that particular data set, and we are going to analyze that it is going to affect with the sexual behavior, sexual hygiene, physical activity, and depressions, and also the desire of the parenthood in both the male and female. Because sometimes if the person is going to work in the company, and once the COVID-19 is going to affect with their business, so the company is going to like kick the persons from their company because they want to continue with that particular person. So the person or the employee under the mental stress, so that particular person is unable to do the daily routines, and so it is going to affect their parenthood. They are under stress. So we have to more careful while this kind of biological virus or biological weapons is came into the world. So we have to more preserve. Okay, and also we have to use the different technologies to protect our countries and also our world from that kind of viruses. Now you see, like we have data collections. Okay, so this particular like data collections, we are going to collect the data from the 262 respondent, including the study of the 30% male, female, and 62% male. And you see, the above, we are going to study the age group from the 18 year of age from India, above 18 years. And we are going to ask the survey, completely out survey. In that particular survey, we are going to consider like age, occupations, economic status, gender, and chronic medical illness. Okay, if the person is already having some illness, so we are also going to focus whether the person is already suffered with the diabetes, already suffered with the sugar, or already suffered with the heart attack. Okay, you see the coronavirus is, you can say, it is mostly effective only those person who's having already illness. They already like suffered with the different disease. So it is more harmful for that kind of person who is already suffered with a different kind of disease in their previous or in their past. Okay, and you see the statistical analysis that we are going to perform using the OLS, and we are going to use the multivariate logistic regression analysis, and we are going to perform all the analysis on the Python 3 engines and R squared. Okay, then after that we are going to calculate the value of the prediction, and the p-value is greater than 0.5 is considered to the statistical significant. Okay, now you see the workflow adoptions to obtain the results. First we have the data collections, then data preprocessing, subset selections, then we have the fitting OLS models, then data analysis and estimations, and finally we have the output. Like we already discussed, first we are going to collect the data from the different survey or different questionnaires that we prepared. Then after that, once we have all kind of data, then after that we are going to remove all kind of noises or all kind of unwanted data that is came into the picture. So we are going to remove all the unwanted data from our data. Then after that we are going to divide that particular data into the different part, then or different models. Then after that we are going to perform the analysis, and also we are going to estimate, okay, whether the output is the correct or not. And that particular concept is going to work in the perform the operations on the Python 3 engine with the pandas and GPU as a backend with the RAM of 12 GB. Okay, now you see in this particular analysis, we are going to design the parenthood before and during the COVID-19 outbreak. So we are going to analyze both kind of data. Like we are going to analyze whether the COVID-19, if the person before the pandemic and after the pandemic, what is the status, what is the mental status of that particular person before the COVID-19 and after the COVID-19. And also we are going to analyze like depressions, anxiety, hardness, mental stress during the COVID-19 outbreak, and also like sexual hygiene during the COVID-19 outbreak, and the smoking, drinking habit during and COVID-19 pandemic. Then the frequency of the physical activities during the pandemic, financial anxiety during the pandemic, and also the sexual intercourse during the COVID-19 pandemic. And also like we have the different kind of age groups, so they are interested to watch the different videos and different movies. Okay, so we are going to analyze all kind of, we prepared all kind of questionnaires, and we shared that particular questionnaires to all the age group, and we are going to collect the real-time data set. Okay, then you see the dependent variable that are desired the parenthood during the COVID-19 outbreaks with the OLS regression result. You see here, we have like age, occupation that we already discussed. We prepared the questionnaires on the basis of like age, occupations, economic status, chronic medical illness, under which zones does yours, like town or city. Then after that we are going to frequency of the sexual intercourse before, during, and also the like drinking habit before and during, and also we are going to study, we are prepared the questions that are related to the watching porn before and during, and also while like sexual hygiene, safe sex, financial anxiety, and desire of the parenthood. So we are prepared the questions based on the different variables. Okay, and we have the like we prepared the different questionnaires, and we are going to categorize all the questionnaires into the different domains, so that we can easily analyze whether this particular data or this particular informations are useful to analyze whether the COVID-19 is going to affect in all the areas. And we are going to say that then after that we are going to overcome the lower sensitivity of the RT-PCR. This is a study of the X-ray images to identify the coronavirus. Then after that, our next objective is that how we are going to analyze the data. If we have the data is the image data, and especially we are talking about like X-ray data. And first we analyze the data, that is the text data. Second, we analyze the data, that is the survey data. Third data that we analyze is the X-ray data. So we have we worked in the different kind of data. Like first start with the text data that is already available into the Kaggle. So we are going to take the data into the different time frame. Okay, and we are going to analyze that kind of data. The second data we prepared a survey. On the basis of that particular survey, we are going to analyze the data, and we are going to give the prediction whether what is the effect of the coronavirus before and after the pandemic. Okay, what is the effect? And third objective is that we are going to analyze the image data, and the image data especially we are talking about like X-ray data, and we are going to use a different kind of models in that particular analysis. Like we are going to use the SVM classifier, and also we are going to use a different deep transfer learning models like such as BGG 16 and Assumption, which are implemented using the Keras and the TensorFlow to detect the coronavirus patient using the X-ray images. So here in this particular study, we are using the different classifier, like we used the SVM classifier, and we are going to use the deep transfer learning models such as like BG 16 and also the Assumptions, which are implemented using the different Keras and also the TensorFlow. And we are going to predict or we are going to analyze on the basis of like recall values, precision, F1 square, sensitivity, and the specificity. Okay, and you see here like these are the different models that we used. Then here we give the data description. Okay, so we collect the COVID-19 X-ray image data from the GitHub, and that particular data is uploaded by the Joseph Paul Cohen. He is the postdoctoral fellow from the University of Umbrella, and he's upload that particular data, and we are going to use that particular data, and we are going to utilize like 104 positive COVID-19 and also and normal chest X-ray images. Okay, now you see this is our models. Like we designed this particular models to analyze the data. Okay, so first we have the chest X-ray image data set. Then after that we are going to load the BGG 16 pre-trained models, and also like load Assumptions pre-trained models. Then after that we are going to calculate the global average pooling 2D. Then fully corrected layer like FCL with the dropout 0.5. Then after that we are going to rectify the linear unit ReLU into 98. Then after that we are going to FCL with the setbacks. Then after that we are going to able to identify whether the person is going to affect with the like whether the person is corona positive or the corona negative. Okay, then after that we are going to create the different performance metrics using the like precision, call, recall, F1 square, specificity, and also the accuracy. So in the accuracy, you see we are going to use a true positive plus true negative divided by true positive plus true negative, and false positive and the false negative. Okay, on the basis of these particular matrices, these particular analysis, we are going to say that the like person is going to affect with the corona positive or the corona negative. Okay, now you see these are now we have the next objective of this particular research. Okay, in this particular objective, we are going to use the CXR data set, and the number of like data set, we have the 2313 COVID positive, and also we are going to use like phenomena and the normal CXR images, and it is going to be utilized by the various transfer learning models, and this on the classifier that are including VGG16, GoogleNet, and the XPSL. So here we are using the different models, and the data set is also different. Okay, and here we are going to use a large amount of data set, and as compared to the previous model. Okay, now you see these are the descriptions of the different models that we used in our like analysis. Now you see here we are going to design the models. Okay, so like you see in the algorithms, we have the input as the we are going to use the like CXR images, and that particular images is contains like COVID-19 positive, negative, and or phenomena images, and we are going to resize the size of the training pictures like 224 into 224 into 3 pixels. Then after that, we are going to load the pre-trained models like VG16. Okay, these models are pre-trained. We are going to load all the models in our data set. Then after that, in the training phase of the VG16, we use like global average pooling 2D, followed by the FCL with a dropout of 0.5. And we are using the different functions like FCL with the ReLU 98. And finally, we are going to FCL with the softmax as the output layer. Then after that, we are going to, in the training phase, we have the GoogleNet and the assumptions. We use a FCL with the dropout 0.5, with the, followed by the FCL with the ReLU 98. And finally, we are going to use a FCL with the softmax as the output layer. Okay, then after that, we are going to create the different classifier like CF1, CF2, and the CF3. These are the different classifiers that we created by layering the 2 FC layers on the top of the future maps and the softmax layer. Then we are going to divide all the images in the data set, and we are going to train and test in the proposition of like 80% training, and the 20% we are going to use for the testing purpose. Okay, and using the training data set, we are going to train the classifier that is already created into the step number 6. Okay, so we have the 3 different classifiers. We are going to use a classifier onto the training data set, and the training data set, we have the 80% of the data, and the 20% is a testing data. Okay, so in the step number 9, using the validation set, and it is going to produce the accuracy of for W1, W2, and W3 in the future map. Then we are going to determine the fuzzy measures value here, classified like WI divided by W1 plus W2 plus W3. Then we are going to resize the size of the images, testing pictures like 224 into 3 pixels. Then on the basis of the testing sample, we are going to learn the classifier that is going to, that is created by the predictions score like P. And the step number 13, using the fuzzy measures F and the supply chop with the predictions score P to get the final prediction score. Then after that, we are going to, in the final, we are going to score to determine whether the person is affected with the COVID-19 or the not. Okay, so in this particular algorithm, first we are going to use the CXR images. Then after, we are going to like scale up and scale down the size of the images as per the dimension. We have to use like 224 into 224 into 3 pixel. Then after that, we are going to use we are going to load the pre-trained models that is already exist like VGG16, GoogleNet, assumptions. Then after that, we are going to use the different classifier, and also we are going to create the different classifier like CF1, CF2, and CF3. Then after that, we are going to divide the data set into the 80% training and the 20% testing purpose. Then after that, we are going to train our models by using the different classifier. And finally, we are going to reach to the fuzzy measures like WI is divided by W1 plus W2 plus W3. And finally, we are going to test whether our model is going to work as per the requirement or not. If our model is going to work as per the requirement, it means our model, that designed model, is working as required as possible. Okay. Then after that, you see, we have the performance metrics. On the basis of that particular metrics, we are going to say that like 453, 450s, 454s. Okay, that particular matrix is designed by using the different models like majority votings, signal intervals, and the fuzzy achieved by the accuracy like 98.2%, 98.56%, 99. Then we are going to receive the accuracy of 99.57%. Okay, it means that if we are going to use the fuzzy in our models, so it is going to increase the accuracy of our desired model. Okay, now with the sudden surge in the COVID-19 all over the globes, it is become we have to use rapid testing methods to test whether the person is effective with the COVID-19 or not. Okay, so we are going to rely on the different testing mechanism, and also we are going to distribute the different devices to the person, and it is safe to provide the patient information guests without visiting the hospitals, thus avoiding the social contact through the fuzzy inference system. So in this particular objective, we are trying to give the different devices, or we are going to distribute the devices, medical devices, to the patient, or you can say to the public, so that the public is going to use that particular devices, and based on that particular devices, the person is able to understand whether I am affected with the corona or not. Okay, now in our government, if we are talking about like Indian government or any of the government we are talking. Okay, so first at the starting, we are going to go for the hospitals and we go with the checkup and all that. Then after that, we are going to analyze whether I am affected with the corona positive or not. But if we are going to provide some IoT based devices, or we have the some smart devices with the person, so the person is actually analyze whether I am affected with the corona or not. Okay, so it is also one kind of you can remove the spreading of the coronavirus in this this kind of device distribution to the public. Okay, so in this case, also like if we have we are going to distribute the devices to the public. Okay, so the public is also going to send the data to the hospitals or to other government agency. Okay, on the basis of that, we are also going to perform some analysis. Okay, because you see, our aim is to analyze the data. That data is available into the cloud environment. So there are different methods by which we are going to collect the data, and we are going to store that particular data into the cloud environment. Okay, so in this particular objective, we are going to distribute the devices to the public, and the public is going to use that particular devices. Okay, and that particular devices is the smart devices. Okay, so they are going to send the data into the central repository where all the data is set is available. So we are going to perform the analysis on that particular data at that particular time. Okay, now you say like we are going to use like fuzzy logic system. Okay, so that particular system, you see, we have the data collection, data pre-processing. Then after that, we are going to use like fuzzy rule mining. Then we have the fuzzification. Then we have the defuzzifications, and after that, we are going to evaluate the metrics, and finally we are going to identify the result. So here in this particular methods, we are going to use the fuzzy concept to analyze our data. Okay, now these are the different like data collection processes by which we are going to collect the data from the different devices, and sometimes we are going to use the Kaggle repository to collect the data. Okay, so these are the different models like rule tables. We have the different like symptoms like low fevers, mild fevers, high fever. On the basis of the fever, we are also going to analyze the probability of the coronavirus, whether the person is going to affect with the coronavirus or not. Okay, so this is also one kind of analysis. Then after that, we are going to use logistic growth models. Okay, that we already discussed. Okay, now you see the next Internet of Medical Things based on the COVID-19 patient detection. Here you see we are going to deploy the devices over the patient, and that particular patient is going to transfer, and that particular sensor is going to transfer the CT scan images. So we have the low power short distance inference, then we have the hosting layers, then we have the WAN interface, and finally we are going to transfer learning models with the fuse with the fuzzy instable techniques that are cognitive modules. Then after that, we are going to analyze that particular data or that particular report, and finally we are going to decide whether the person is affected with the corona or not. Okay, this is one kind. This is also one models that we designed for the like IoT and the cloud environment. Okay, this is a pseudo fuzzy integral algorithms that we prepared. Okay, to analyze the data. This is the performance matrix by which we are going to predict that whether the person is affected with the corona positive, normal, or the corona negative. Okay, and after that, we also compare our model with the existing models, and we are going to see that our model is as much powerful as compared to the existing models. Okay, then you see IoT based, we also work on the IoT based repository tracking systems for predicting the accidental situations. Okay, so now we are trying to prevent accidental situations that is going to occur in our daily routine. So how we are going to prevent that? Okay, accidental situations. So we are going to use some smart IoT devices. Okay, so here you see we prepared this kind of device like respiration temperatures and the ambient temperature. We are going to deploy two kind of sensors, and that particular helmet is connected with the medical mobile devices, and we are going to send that particular data into the cloud environment, and that particular data is also connected with the parents, hospital, police, okay, healthcare department. Okay, so in this way we are going to deploy our sensor or our different ambient temperatures and the respiration temperature. We are going to identify. On the basis of that, we are going to send the information to the mobile devices, and the mobile devices is connected with the cloud environment, and that particular environment is also connected with the parents, police, hospital, and the healthcare department. Okay, so this is the flow diagram by which we are going to analyze our data. Okay, thank you. And these are the different references for our study. Okay, thank you.
Okay, thank you so much, Dr. Kumar. So I see that there quite a lot of interesting results from the research from Dr. Kumar and his group for the last years. I guess that so many questions will come to Dr. Kumar, but we have a short time now, and we let the questions come at the end of the talks. Now we would like to invite Dr. Land. We should present our second talk. Yeah, so please.
Hi everyone, dear ladies and gentlemen. I'm Dr. Lương Chiêm Lan. I would like to present the subject, a complex fuzzy sample learning model and its application in disease diagnosis. My presentation covers the following 5 issues. The first is an introduction to the problem. The next section is present the background knowledge required to build the model. Furthermore, the model is described in part 3, and part 4 is experimental design for problem of disease diagnosis. And final part is the conclusion and future work. Firstly, I want to talk about the comparison between machine learning and transfer learning. As you know, generational machine learning has created a significant impact and have been utilized in various of practical applications. Each learning task is isolated and single task learning. On the other hand, transfer learning is intended to learn a new task rely on the previous learning task. In certain situations where label data is lacking. Third, transfer learning has emerged as a potential solution, but there are a few issues that need to be kept in mind in intelligent and judgment. The first the first issue, the environment model to make decision, but each environment is different, such as contextually, spatially, and temporally. The second issue, the application domain produce uncertain and dynamic environment. The third issue is collecting data is expensive in terms of time, resources, and analysis. Final issue, most learning process requires source and target data to come from the same feature and domain space. Further, the uncertainty and vagueness in the daily can arise and modify the process. It has been a good interest to design a novel model. This is the reason and motivation for our research. This work proposes a normal model to capture data related to periodic temperature factor and enhance the quality of assist different process. Before present our proposed model, this session presents the notation and definition of fuzzy chamfer learning that we use throughout my presentation. The first is the definition of fuzzy chamfer learning. It combines the fuzzy logic and chamfer learning to address the issue of knowledge in the target context. The second is concept of complex fuzzy set. It is considered an expanded set of fuzzy set. A complex fuzzy set lies within the unit cycle in the complex plane, and the membership function has from above a function with P expressed in the amplitude term and WC on W express the phase term, and the last definition we want to introduce memory complex fuzzy inference system. This is the system consists of 6 states as shown in the above slide. The issue is the primary motivation for introducing novel complex fuzzy chamfer learning framework that combine fuzzy chamfer learning and MCFIT. Now, this is my proposed model framework. It's designed as knowledge chamfer learning framework in which the source and destination domain are related. Is it work? Assume that the source and the destination domain that data have the same dimension but different distribution. The proposed model consists of 4 main steps. The first is adjusting the source domain. The second step is selecting subset in the destination domain. The third step is progress up through adaptation, and the final is combine complex fuzzy rule by and receive the final adaptive rule. The output of our model is use complex fuzzy rule by to predict the output label. This is our proposed algorithm. We input contains some parameters such as source data, target data, training data rate, and size of the sub. The output of this algorithm is an adaptive complex fuzzy rule by to predict the output level. Before present the detail of our proposed framework, some definitions are introduced, which are used in the whole study. To determine the data set of source and the target field that's suitable for the model, we propose a similarly mixture between 2 domains, such as in the slide. definition of fairing stand of the rule and definition of fairing rule and candidate rule, which aim to choose the most significant rule. After that, the step of the model are as follows. The first step is to assert the source domain. In this step, we do following work: calculate the left and the right boundary value of each attribute range in source and target element. Then each value is compared with amplitude and phase interval in source domain. Finally, we use narrow if input value is less than left boundary and expand if the input value is greater than the right boundary. The next step is to select the subset. The purpose of these steps to answer the question how to select data for adoption and to reduce the list information of target sample that require in the rule editing process. The idea of this step is as follows. Take into account the diversity of target data to select the subset that have SICA, okay, and the number of the subsets satisfies the ratio of the total number of sample for the sub and K. The third step of the model is the process of rule adoption. Detail of step is clearly described in the figure 2. This step consists two main actions. First, we need to determine the fairing and candidate rule to point out whether the rule is suitable for the testing data. This step uses the definition of fair rule and candidate rule in the previous section, and then the process of modifying an edge rule is executed. After obtain the set of adaptive complex fuzzy rules, we will change to final step. We will aggregate by remove the same and the weak rule and obtain the final set of adaptive rule for the target data. We prepare to prove the proper model effectiveness for disease diagnosis. We compare our proposed model with assist model and CFIT. The experimental dataset used in the evaluation consists two types: UCI and real-life medical dataset with two label output. There are three datasets: diabetes and breast cancer from UCI, and this is real-life dataset from Thanh Nguyen Hospital. The detail of dataset is visually described in the slide. And the evaluation on three criteria: accuracy, number of rules, and time consumed. Moreover, we have also designed to screen error for experiment. Scarino 1 is used to evaluate the MCFIT performance, and 2 aims to validate the reason capability of complex fuzzy sampling in case of knowledge leverage. And in our experiment, the dataset have divided to two parts by the whole hour cross validation, include changing dataset about 80%, and 20% is for testing data. In the first screening, the complex fuzzy set complex fuzzy rule generate mechanism in MCFIT is used for all training, but in the much less, only 30% for of the training data in the second screen error. Finally, the complex fuzzy rule-based result obtained in the two screen error evaluate on the testing data on three indicator. Furthermore, each experiment was repeated 20 times with the same learning parameter. The following the comparative experimental result of its corresponding data set on the compare index. The first is the result on breast cancer on the respective measure accuracy, number of root, and time consumption. The second is the result on the diabetes data set on three indicator accuracy, number of root, and the time consumer. Finally, the result on real-life data set on three indicator as you see on the above slide. A summary, the data set, the test result on both data shows the effectiveness and significant in term in execute time and the number of rows. It's to get this reason, there are two reasons. Firstly, we selecting the data set for rule adjusting for set. For the set, the processor model select only the subset on the entire training data. The secondary reason is method determine firing room, candidate room, and edit room also have the model to improve faster and faster than MCFIT. However, the accuracy has not been improved because our proper model is limited depending on the selection of data set itself. This is the cornerstone of this study some issue. The first, we propose a no complex fuzzy transfer learning framework in which our model combine fuzzy transfer learning and MCFIT to enhance the graphical fuzzy transfer learning for deal with uncertainty, priority, and second factor in the complex decision-making problem. And we introduce a no definition of firing rule, candidate rule to choose the most significant rule. Our model entity transfer to knowledge to enhance the learning of target tasks from source start. And we use our model to realize dataset to gain result. However, the accuracy of model is still not high, but further work, we focus on the follow work. Future study will continue and add other steps to improve the model accuracy and change some parameter to fit other model in real life application. We focus on the impact of contextual information. We explore of limited and reduced information learning, and last we increase the diversity of real application. This is, thank you for listening.
Okay, thank you, Dr. Lam, for your very interesting and impressive results on transfer learning. So may I send brief comments on the research? Dr. Lam, this is specialized on conduct transfer learning. CC has so many publications in a good journal like IEEE transaction on for this system and ICD system and so many good honor. And he's also internship in Taiwan in NTU and so many other university. And I think that this is a good chance for her if she can extend cooperation with some professor in Taiwan in Tech University. Okay.
Yes,
Okay.
thank you, Dr. Sun.
Okay. Thank you so much. And now we should come to the third presentation from outside from Mr. Sun, Mr. Phạm Hoài Sơn. He will present for the new research about the enterprise architecture, especially for health domain. So please.
Good morning. I'm very happy to present with Wintech professor because I'm an old student in Wintech. I got a master degree of computer science in there, and I graduated in 2008. And my professor is Wan Phong Wang. Now he's working in the IoT and AI lab. Let me focus in my presentation now. My presentation have 4 parts. First, I describe the enterprise architecture, and the second, overview the Vietnam Health Administration, and the third, I develop an enterprise architectural framework. Guidance, I developed the EA framework for health. So the definition of enterprise architecture, the IEEE define an architecture is the fundamental organization of a system embodied in its component and their relationship to each other, and the environment and the principle governing and its design and evaluation. And enterprise often use the term enterprise architecture, but in the governmental context, the same refer to the national enterprise architecture. In the United States, the term federal enterprise architecture. And national enterprise architecture has also been called governance enterprise architecture. So the role of enterprise architecture, it explains how the health information system process, organization units, and stakeholders in the organization function as a whole. It can increase the potential for cross-public sector review and reduce the duplication and thus lead to reduce costs. It describes and explains the relationship between projects and help in both system acquisition and change management. It includes architectural model, principle, and standard from the context and an enterprise architecture. In the enterprise architecture approach, health public administration is viewed as a collection of inconsistent organizations that have different business process and information system. Here is a list of enterprise framework in the world. There are 17 frameworks, but there are only a few famous frameworks is used They are Jackman Enterprise Architectural Framework and the Open Group Enterprise Architecture Enterprise Framework and Federal Enterprise Architectural Framework and Department of Defense Technical Reference Model. And the final is standard and architecture for e-government application. Here I propose two examples of enterprise architecture is the Open TOGAF Architectural Framework and the Federal Enterprise Architectural Framework. In the TOGAF framework, they can see they provide the phase. They divide framework into phase and own phase to address the requirement management in the center. For Federal Enterprise Architectural Framework, it develops the current architecture to the future architecture into the core architecture, include business architecture, data architecture, and application architecture, technology architecture. Second, I want to overview the Vietnamese healthcare to administration to you. Here we have Vietnam have the 4-level administration. They are central government and province level and district level and commune or ward level. In the central government, they have the health military and in health military they have the hospital and each of other military also has the hospital too. And the province also have the hospital and health department. In the district level, they have a district health department and the commune or what they have the dispensary. So in the red line, describes the direct management and the blue line is the indirect management. So in the central level, they is a place to issue policy and also provide some public service for citizens and business. It also have few central hospital. Province level provide a lot of public service for citizens and business, and there are several hospitals in province. In district level also provide public service to citizens. What or commune are the 4th administrative level involved in providing public service. And so Vietnam has one ministry for health and 63 health department in province and more than 700 health department in district and more than 11,000 dispensary. That's describe the complex health public service in Vietnam. So you can see several types in health public service is provided at the both of administrative level. So many types of database are not synchronized. Many health agency participate in the one process of providing public service. So citizens and business take a time to gain other license before apply to a final license. There are no population database and other database that have not been integrated. So citizens still have to certify their document at the legal agency. And the reform of health public service depend on the modified policy of health military, and the health department on only implement the policy. So to reform the health public service process, the health department must wait for health military. So it takes a long time. overview the health administrative. You can see there are 4 sectors provide the health public service. G2C is mean government to citizen. It mean government provides health public service to citizen. And G2B is mean government to business, and G2C is mean government to government, and G2E is a government to employee. So you can see the G2C and G2B is a front line of service, and G2E and G2Z is a back office service, and G2C and G2E is mean individual for individual service. On G2B and G2Z is organization service. Beyond the Vietnam healthcare administration and some enterprise architecture, I propose a health enterprise architecture framework for Vietnam. You can see they have 3 levels, 3 phases. First phase is police and state and statutory, and the core phase is a business architecture and data architecture, application architecture, and technology architecture. And the final phase is guidance and management. And before they decide the architecture here, they must issue policy and statutory, and guidance and management is used in the designing phase and implementation phase. So I focus on the core architecture, include business and data, application and technology architecture. For business architecture is a list of healthcare service for provide to citizen and business. It means service in hospital and service in government agency, and the service for management in the hospital and in the healthcare agency. Based on business architecture, I designed to application architecture include the health service delivery and prevention, coordination and referral, and for staff healthcare agency. We also have the care plan template and management in the agency business. We also have the management information on access registration and maintain schedule. And the data architecture, the Vietnam government have to build a national health database. Beyond that, an own database is collect from hospital and collect from clinic and to put to on national health database. And the technology architecture describes how to build the application and how to save application by security service, and how to integrate application through the enterprise service bus, and include the infrastructure service. Here is a 7 steps to guidance and develop EA framework for e-health. Step 1, identify the purpose of the architecture, and step 2, identify the business question, and step 2, identify assumption and business rule. And step 4, identify your framework. And step 5, create a meta model. And step 6, identify the model need to the architecture, and the final integrate the architecture. So how to cooperate between UNITEC and us, and I propose some cooperation via orientation follow. First is we can consult and build enterprise architectural framework initiative for health organization, and we can develop the health platform for hospital and health organization, and we can research and adapt the mobile technology on medical examination and treatment activity. So let me stop my presentation here. Thank you for listening.
Okay, so thank you, Mr. Sun, for presenting some brief results on the enterprise architectures for smart health. And it's good that Sun also presents some corporations in terms of an EA framework now. And I think that we can start talking about that at the end of the workshop. Okay, so thank you again for your presentations. Yeah, okay. Now we also finished the first part from Venu side with the 3 first presentations, and now we change to the second part from the presentations by the UNITEC University. So by this way, I would like to invite Professor Chuan Woo Chang to chair and lead the 2 presentations at the end. Is it okay for you?
Yes, as because of time have delays more serious, so I will introduce the first presenter, Professor Xuanting Zhang. Xuanting, are you here? Okay, Xuanting, please turn on your microphone. Yeah. Okay, please shorten your presentation. Okay. Okay, please. You can share your slides. Okay, please.
Hi, everyone. I'm Xuanting Zhang. I'm from Department of Electrical Engineering in UNITEC. And the title of my presentation is Detection of Lung Tuberculosis Lesion in Chest X-ray Image Based on Artificial Intelligence. Okay, this research is a collaboration work with Dr. Oh and Dr. Chen in Department of Internal Medicine, National Cheng Kung University Hospital, Doliu branch, Taiwan. And basically, they proposed the idea of using AI for X-ray image analysis and provide us the chest X-ray images. And Mr. Chen Wei is my graduate student, and he's in charge of this work. He just graduated in this July. So the contents of my presentation include introduction, tuberculosis lesion segmentation, and the proposed methods, experimental result, and finally conclusion and the future work. So first, I will talk about the research motivation because tuberculosis (TB) is an infectious bacterial disease characterized by the growth of nodules in the tissue, especially the lungs. And according to a report from Global Burden of Disease, TB is the 13th leading cause of death worldwide in 2019. So it is still an important and popular illness for human beings to deal with. And early detection can be treated with a course of antibiotics for 6 months. And the chest X-ray is an affordable and rapid diagnosis and technique for detecting TB. So according to the physician's opinion, there are 5 major symptom types that can be observed in X-ray images. As shown in this table, the first one is in filtrations, bronchiectasis, and opacity, consolidation, cavity, miliary, and pleural effusion. But in our study, there is only 2 types of TB lesion used due to the data availability in our current data set. And due to the limited time, so I skipped the detailed description about the lesion. And here are related works. We know that semantic segmentation of TB lesion can be studied by using computed tomography and chest X-ray images. And there are many deep learning-based computer-aided lesion detection methods, and the UNet model is very popular according to the literature survey. And however, the detection results are only show as bounding box and or the heat map, not a detailed region. So it is always better to obtain a fine-grained semantic segmentation result and the detailed classification of the TB lesion type. So here are 2 examples about 2 types of TB lesion. The first image is infiltrations bronchiectasis. As shown in this figure, there is a tram track appearance of parallel opacities. And for opacity consolidation, shown in this image, the air fills the airway in lungs. So here we demonstrate an example of the detection result of TB lesion labeling. In left-hand side figure, this is the original image, and in the right-hand side, it shows the TB lesion, and for yellow, the yellow part shows the infiltration bronchiectasis, and the red parts shows the opacity consolidation. So in our proposed method, first we use image preprocessing and also use post-processing for the detected result. And we use data augmentation, and we tried to use various UNet-based models. And finally, we have an ensemble model for the 5 UNet model we use, and we will have a systematic overview. So according to our experience, it's very useful for medical image processing. So before the classification, it's always better to use image preprocessing scheme on the original image. So in our method, we do the long region of interest extraction, and we also try to use bone suppression on in the X-ray image. And the third one is a contrast-limited adaptive histogram equalization, CLAHE, to enhance the texture information in X-ray image. So here is the result. Because the original image is not containing only the exact long region, so we can extract the long region only. And of course, the method, there are many methods has been proposed. So we try to extract the region of interest only for the long parts. And there are also some methods proposed to suppress the bone parts in the X-ray image. And so there's a ResNet bone suppress method, and shown this here. And when we input a long RI image with some deep learning network, we can obtain the bone suppressed result. And the third method, pre-processing method, is CLAHE. It can improve the quality of image, so especially enhance the textual characteristic in the CXR images. So as you can see in the right-hand side image, the textual information is more clear. So we test 8 combination of different pre-processing methods. So since we have 3 pre-processing methods, and there are 8 combinations. And after we detect the lesion result, we perform the morphological opening operation on the result to exclude some single points. And the lesion segmentation image is resized to the original one and attached on the original image, so we can observe the lesion directly from the original X-ray images. So, and before the training process for the deep learning network, we do the data augmentation, which include rotation by minus or plus 10 degree, and image translation and horizontal flip. So originally we have 92 training image. We can finally obtain 736 images. We in our study we use 5 U-Net-based models. The first one is the basic U-Net model, and attention U-Net, U-Net plus plus, and attention U-Net plus plus, and the fifth is the PSP attention U-Net. So the detailed principles and application about the U-Net based model can be found in their reference papers. And we use ResNet 50 as the backbone in the U-Net model. So previous study have shown that the pre-trained on the ImageNet data set is useful in the CXR image analysis. So so the pre-trained parameters of ResNet 50 on ImageNet are loaded to the U-Net backbone, and this table shows the number of convolution blocks in ResNet 50, the red circle. So we also try to combine the 5 different U-Net-based models to obtain an ensemble one. As shown in this figure, the output of the 5 models are multiplied by a weighting vector W1 to W5 respectively by testing the different combination of the weighting factor, we can further improve the segmentation result. And the loss function during the training stage is also an important factor that can affect the performance. So here we try to use 3 different loss functions. The first one is cross entropy, and the second one focal perversity loss and hybrid loss. So in the training stage, original CXR image are used, pre-processed and used for data augmentation with the label, region label. The region labels are also sent to the training network, and finally the train model can be obtained. So in the test stage, the same image pre-processing method is applied to the test images. Then we authorize the train model to predict the segmentation result separately, and also the ensemble one. And the image post-processing will resize the image into its original size, and then the detected tuberculosis lesion will be displayed in the CXR image. So here are the experimental result. First is the computation environment can be shown in these tables. And here this table shows the different the number of the image of the different lesion. So in this our data set, we have 33 infiltration lesion in the image, and the 22 images including opacity consolidation, and the 55 images with both the TB lesion and the 3 normal, 3 normal image without any TB lesions. So after the doing the data augmentation, we have 736 training set image, and during the training we use 9 image at the validation set, and finally in test stage we have 12 image, which include 3 normal image without lesion. So here are the definition of the evaluation function. First one, we need to know are there any lesion in this CXR image, and we must know the lesion type. And the second one, once we detect the lesion, we have to classify the lesion, and also segment the region. And so we use 4 evaluation function: the mean, precision, recall, F1 score, and the IOU. So here are the test results for 5 unit-based model, and in this model there are different pre-processing methods showing this current, and the loss function are all cross entropy. And so here are the detection result. And in this table, we try to use different loss function to test to obtain the test result. So as you can see, the mean IOU and F1 score can be improved. And finally, we perform the ensemble model, and by try to using different combination of the weighting factors for the 5 unit-based model. So after using the in-demo model, we can see the accuracy can all be improved to 1, and the IOU and F1 score are also improved. So here are the comparison between in-demo model and the best single model. So basically, in-demo model is all better except the precision. So here I demonstrate some text result. So this column shows the original image, and the second column is the ground truth. The third column is the detection result. Finally, we attach the detection result on the original image, and we can observe where is the lesion and what's the type of the lesion. And here are 4 other image, the 4 other the test result. And if we input an normal image without any lesion, then the model, the approximator won't generate any false positive. So in conclusion, we propose a deep learning-based approach for segmenting the 2 types of TV lesion in CXR images. And 3 pre-processing schemes and their combination are used for dataset imaging. And the in-demo model for the 5-unit model with backbone network ResNet 50 achieved the best result. In our future work, we will collect more dataset image, including other TB lesion types, and perform multi-class detection and segmentation. And we will also try to utilize more new model that can improve the system performance. And the detailed information on lesion class, location, number, and the region area in CXR image can be used for TV severity evaluation, and so that's why we want to detect different lesion types, and we want to know their location, and we want to know their region size, which will be helpful for TV severity evaluation. Okay, thank you for your listening.
Okay, thank you, Professor Zhang. Thank you for your great words. And if everyone have any question, we can discuss it later. Okay, now I will, it's my turn to, okay. Okay, in order not to delay everyone's lunch time, so I will speed up and shorten my speech. This is my topic today. The topic is vision-based heart rate and the respiration detection. Okay, I'm Chuan Zhang, the Deputy General Director of the Service System Technology Center at the Industrial Technology Research Institute, Taiwan. I'm also the distinguished professor in the Department of Computer Science and Information Engineering, UNTech. And I am also the president of the Chinese Image Processing and Pattern Recognition Society, who is the largest research society for image processing in Taiwan. I have been engaged in machine learning research for about 20 years, and I focus on developing technology that can really be applied to industry, such as medical image processing, infant crying analysis, and automatic optical inspection. Biological signal measurement can basically be divided into contact-based and non-contact-based. There are many contact-based devices in clinic. For example, when measuring the ECG, medical staff need to attach the electrode to the patient. And the oximeter should clip on user's finger. And the wearable device should be worn on the wrist. However, those contact devices may cause discomfort to users, and the external wireless may also cause danger. On the other hand, we can use a thermal camera and the RGB camera to capture vital or tiny changes from face to measure the biological signals. So here we adapt the principle of head oscillation. When the heart systoles, the blood flow to the outside is very strong, and the head will unconsciously shake slightly. Based on this subtle movement, a normal measure is proposed to capture head movement and thus to further detect heart rate and respiration. The advantage of this measure is counterless this effect by light influence. Okay, this is a flow chart of the heart rate and the respiration rate measurement. There are 4 main parts: pre-processing, displacement calculation, signal analysis, and heart rate and the respiration rate measurement. Here we use a measure published in CVPR to extract the feature point on the face. From the extract face feature point, we define 7 features. Then the displacement of the successive frame of the 7 feature points could be represented as this equation S, where Di denotes the displacement of the successive frame of the ith feature point. And according to the equations, we can obtain the displacement of the 7 feature points in the time series from channel 1 to channel 7. And as mentioned before, the head movement usually involve various unaware movement. Those unconscious head movement may caused by blood flow, breathing, blinking, muscle transitions, and facial expression. This unconscious head movement make it difficult to observe the pulse signal. Therefore, we use the fast ICA to try to separate these signals. The figure A shows original signals, and the figure B is separate signals. Then we convert the ICA signal to frequency domain through through the Fourier transform by this equation. And the figure B is the result of after faster Fourier transform. Okay, in general, the resting heart rate of a normal adult is about 40 to 120 beats per minute. In terms of heart rate, heartbeat frequency is about 0.7 to 2 Hertz. And the resting frequency of normal adult is 12 to 20 breaths per minute. That is the respiratory frequency is about 0.2 to 0.4 Hertz. And Butterworth's bandpass filter was applied to shift to filter out the significant characteristics of the heartbeat and the respiratory. Finally, we select the channel with the largest power spectrum variation to estimate the biological signal, where the maximum power and the average power of the ice channel can be obtained by these three equations. Okay, and finally we use two Butterworth bandpass filter to filter out the frequency of the breathing and the heart rate, and then the heart rate and the respiration rate can be estimated by these equations. Okay, in order to verify the effectiveness of the proposed measure, we use the Mahalanobis HCI data set to verify the system. The data set was correct the ECG and the respiration amplitude of each volunteer. There are 30 healthy adult volunteers, including 17 women and 13 men, age range from 19 to 40 years old. We use the mean square error, confidence interval, maximum error, and the Pearson correlation coefficient to identify the accuracy of the system. For facial heart rate measurement, we compare two well-known measures, Thomas and Bedakins measures. The proposed measure attained the minimum RMSE and the confidence interval. The average error of the facial heart rate is about 4 beats per minute. For facial respiration measurement, we also compare two well-known measures. Gastomin and the LIN. From these results, we can see the major performance is similar to Lin's measure. The average error of facial respiration rate is about 2 times per minute. Okay. In addition to testing with data set, we also ask many people to perform actual measurement. Let's take a look at the video. We use a wearable device that can measure respiration and heart rate for comparison. Although this wearable device may not be accurate, as you can see in the movie, there is not much difference between our measure and the iWatch and the watch. And the heartbeat is about 12, about plus or minus 2 beats per minute. Okay, this is another demonstration. We have implemented the biological signal detection techniques on the Bobby robot. It takes about 20 seconds to measure the heart rate and the breathing rate and the body temperature. This cube robot can be placed in an epidemic prevention hotel or in the ward. So this is the demonstration. And this is another demonstration. In this demonstration, this technology can be applied to both single person and the multi-person situation. Okay, so this is for single person, or just click the star, then we can measure his or her heart rate and the breath rate. And we can also measure in multi-person situation. We can identify the gender of the subjects in this technology, we have obtained 6 invention patents in the United States and Taiwan. Okay. Conclusion. In this speech, I introduced the function of the heart rate and breathing rate measurement. The averaging error of facial heart rate is about 4 beats per minute, while the error in respiration rate is about 2 times per minute. Finally, I hope the pandemic will end soon, and we will have the opportunity to meet physically and have a further discussion on the cooperation. Wish you all good health and all the best. Thank you all. Thank you.
Okay, so thank you, Professor Chuan Chuanju, and all the correct member from Taiwan to present very impressive result. Okay, so now we just close the second sections about the presentations, and now we move to the last part of the workshop today. Is the discussions and about the corporations and some Q&A. And for this part, I would like to invite Professor Sun Tu and Professor Chuan Wu Chang to host the last part and give some information. So please.
Okay, so Professor Chuan Tun Tun, you want to first?
Okay, so thank you, Professor Chuan Yu Chang. I think you and me have the same name. Okay, so thank you very much, the presenter, for very nice and interesting presentation. So before we open for question and answer, so from Vietnam National University Hanoi, we would like to propose some kind of collaboration. So we found that there are so many common things. We can establish some joint research group, and we should think about how to write a joint proposal to get the fund from Taiwan and from Vietnam government. And we can also co-supervise PhD student and master student. And from those activities, we can have a joint publication. And we also share the information about conference and documents or activities in both sides in this field, apply GAI for smart healthcare. And I found that you also talk about some devices like a smartwatch and something like IoT devices as well. So we think that we have so many potential in future collaboration. So what about your opinion?
Yes, thank you. I think that is a very good opinion. As my knowledge, I know in Taiwan, National Science and Technology Council has provided Taiwan and Vietnam bilateral projects. Maybe we can try to apply this project.
Yes, yeah. That's a good idea.
Yeah. And I think besides, in addition to the National Science and Technology Council project, we have also self-funding support projects in currently is performed. So I will show my, we have corrected the topic here, and I can show to you, and then you can, we can have a group, the research group, to join the research topic. Can you see the topic, my slides?
Yeah.
Yeah. Yes, I have corrected some medical imaging related research project at our centers. Okay. Okay. This is my currently research about the medical imaging. There are the first one is lung tumor detection from chest X-ray image, and the second is to detect or to distinguish the fresh or the fracture on spine CT image. And the third is the update is the newest project from the National Science and Technology Council that is use the GAN generative advisory network of heterogeneous medical image in clinical application, so especially apply it in hypocomus sparring whole brain radiotherapy. And we also have applied the machine learning or deep learning technique to smart lives. So I have developed a comprehensive smart baby monitor to detect and to analyze the baby crying and detect the danger behavior of baby. And the last one is I just present the vision-based facial heart rate and the respiration. And Professor Xuanting Zhang have also 3 topics about the medical image. There is the first one is lung TB lesion detection, and the second is early stage breast cancer detection, and the third is AI method for pancreatic cancerous symptomatic classification. Okay, and Professor Wang, he is the advisor of today's speaker, Feng Hai Sun. Yep, he is 2 topics about the abnormal function of AFS, and the second is jet analysis. And the Professor He Qiancheng is also have 2 topics. The first is urinary stone, and the second is automatic phenomenon source segmentation in chest radiograph. And Professor Xu Zhongchuan is he also applied the machine learning in X-ray image, especially in endotracheal tube and the cornea. Okay, so there are 5 professors here, and we are welcome you to join us. And we have also welcome to maybe we can have some student exchange, or we can advise PhD students. Yeah, so that's my the medical relative research project and the opportunity here in our IRIS Center. Thank you.
Thank you. So there are so many research subjects. It's very interesting. So could you send us this slide, and we will have an internal discussion, and we assign some professor to
yes.
work with.
Yes, I will send the slide to you after this this workshop.
Yeah. Okay. Thank you. So, any question and comments from the audience?
Yeah, in our schedule we have a group photo, so yeah, maybe we can turn on everyone's camera to take a group photo.
Yeah. Thank you. So please turn on your camera, everybody. You can lift your mask if possible.
Okay, please turn on camera. If you have camera, please turn on. There's a great opportunity, so it's a take a crop photo. Okay, so Lê, please take the photo.
We wait 1 minute more, so everybody turn on the camera.
Okay. Okay, smile.
Dear Professor Chang, so can I have one question?
Okay, please.
Also, thank you, Professor. I am Vietnamese student, but now I am studying in Japan now. So when I see your slide, your research topic about vision-based heart rate and respiration rate detection. So which sensor do you use for the heart rate and respiration rate detection, Professor?
You say why I use the facial, right?
No. Yes. Professor said the vision-based, right? So which sensor Professor use now?
Okay, we just use today's topic. I use RGB camera.
RGB camera.
Yes, besides the RGB camera, we also have used thermal camera.
Thermal camera.
And both camera we have used and have different and similar performance. Yeah, they can be applied in different application and different fields.
For the real time, right, Professor?
Yeah. Both on real time, and we can implement it in edge computing, in the embedded system, not in huge or expensive computing devices.
Thank you very much, Professor. So.
Okay, great. I think we have 5 speaker have speech today, and we have exchanged our collaboration thoughts. So I think there's a great great workshop, and we have good results today. So maybe we can have a connection windows, and we can continue to keep in touch, and we can try to, the first thing is to join the project national and try to apply the National Science and the Technology Council project in the first step. And then we can, I will send the PPT to you, and you can join or select the topic you are interested in. Then we can have a group. Then we can have a joint research group to do the deeper research and publish the paper. And the third one is then we can co-advise the PhD student, or even we have a student want to, for example, my student want to go to Vietnam, and you want to send your student to FinTech, we are all welcome. Okay.
Okay, so thank you very much. I think that, we have many
Okay.
potential connection. So
Mhm.
please let us to exchange information by email, and to start the Zoe project is a very good idea. And then from that we can put many person, many faculty and PhD students both together. So we welcome you and so student go to Vietnam, visit our university and take some days or even some months for internship as our PhD student. Yeah.
Mhm. Okay.
Okay. So thank you very much.
Thank you. Okay. I think it's lunchtime.
Yeah.
Okay. I thank you everyone, and thank you your
Professor Wang. Professor Wang.
Professor Wang.
Yeah.
Professor, yeah.
Chang. Professor Chang. Right? You are Chang.
Oh, Professor, yeah.
Sorry. Yeah. So can you talk to my professor that I meet him and Yun so much? Okay.
Yeah. Okay. No problem. He's my colleague. Mhm.
Yeah. Thank you.
Mhm.
Okay. So thank you and have a good night.
Mhm. Okay.
Okay. So thank you. Bye bye.
Thank you. Thank you, everyone. Thank you.
Thank you.
Thank you. Bye bye.
Option.